Morning, everybody. The today's session of this non-destructive evolution, I would like to move on with respect to new application. The role of this non-destructive evolution or non-destructive test techniques, different techniques. So far, we have been learned such as radiographic technique, eddy current testing process, ultrasonic testing processes, liquid penetrant testing processes, magnetic testing process, etc. So different kinds of testing processes or methodologies that has been utilized in the case of our aerospace industries or aircraft industries for clearly observing different aspects or different defects considering in the manufacturing of this aviation things. Let's move on with respect to the range of this composite level structures up to the mark of this composite level of structures to be inspected and what are the defects that are being considered in the manufacturing areas, particularly on the light-weighted objects and heavy weight carrying objects, which is playing a tremendous role in the present day's world related to the aviation technology. We would like to progress with respect to the composite materials. These are the materials which are widely utilized in the number of industrial sectors for different scope of applications or different range of wide range of manufacturing aspects in the industry, such as the aerospace parts that will be utilizing in the manufacturing of aeroplane parts, even in the boat buildings, which will be having a non-reactant with respect to the H2O considerations, such as this aluminum, magnesium, titanium, and their alloys, which are having less density and which are having the capability of holding heaviest objects, nothing but having a capacity of high tensile strength. And even it plays a major role in the case of this automotive industries also in different automobile applications, manufacturing of cars, car decors, and even bikes, two-wheelers, four-wheelers, 6, 12, 14, etc., which are light in weight but high in strength, absorption or resistant with respect to the forces that has been implied over the materials. And at most in some of the sports parts manufacturing, this composite materials plays a major role. Here, there are different forms of this composite materials. Depending upon the more flexibilities regarding it, as per the design criteria, it can be molded and transformed to a particular dimensions, having a heavy stiffness and strength. Even have a scope, major scope in utilizing spatial technologies such as manufacturing of the satellites, which is having the recyclation capability that the materials will be sending to the space. Marine automobiles manufacturing. Most probably, the structures in order to withstand or buoyant with respect to the aviation range, that is due to the wind fluctuations, cope up with respect to the temperature that is being developed at the nominal range, that is having the zero gravity range, particularly in the case of space. And within the attractable areas in the stratosphere range, where nominally the cargo planes or else the domestical planes which used to for transportation, used for the transportations. In such a way, this composites plays a major role in almost all the cases. Coming to the point of this aircraft analysis, particularly this non-destructive testing plays a major, or we can say a crucial range, actually, that even a simple crack that leads to pass the high pressurized winds in the case of transportation, in the range of the transportation, because of its lightweight but having high stiffness that is compatible with respect to the load implications, even dynamically might be happen at the particular situations. Having the capability of carrying the heaviest loads. Coming to one point, if at all the unbearable situations or loading conditions has been considered, or track deviations with respect to its radiology has been diverted, it leads to an hazardous situations in the case of this aviation technology. So, indeed, to cope up with the high pressurized winds that are not to be entered into the internal parts of the planes when it is in a dynamical motion, this NDT plays a major role for inspecting perfectly whether the permanent fixation of joints at different places has been considered exactly as per the standard specifications or not. So that is the consideration of this aircraft analysis. Those are the pigmentation sources of this aircraft analysis. Here, carbon graphic composite materials are trending in the present day's world for the generation of this commercial aircraft such as Boeing 787 and even the normal Airbuses, which are used for the transportation towards the shortest distances, or nominally we will say the domestical airplanes, which will be used to travel from one state to the another state or from one district to another district, so on. And the inspection methods such as tap hammer or ultrasound, these are the earliest stages of testing methodologies, but even still they are utilizing for the inspection in the range of these composite structures, particularly in the case of our aircraft manufacturing industries. Coming to the limitations of its strategy, the inspection results on the experience of the inspector, nothing but skills required for the person in order to examine clearly in this aircraft analysis. Majorly, this analysis plays a crucial role for getting or seeing the minute or even the ranges of these defects, considering in the micro range also. And even another one more limitation, it do not allow the scanning of large areas, particularly the areas in an economically efficient manner. Coming to the active thermographic technique, as we all know that thermography is nothing but the IR rays, infrared thermography, which are utilized at a high range of frequency with respect to the temperature factor, utilized for inspecting the materials at an atomic range. So in the range of in the case of this composite materials inspection, this active thermography technology plays a major role for identifying the internal structures and its integrity of the composite materials. It enables large area measurements in order to be performed, and results which will be impregnated with respect to the bus interface units connected for visualizing or examining in the case of this differing in its radiography or else the pictorial representations and digital representations. Nominally, these inspection systems are very much easy to operate and doesn't require any of the skillful factors in order to commence the performance, the inspector performance. Majorly, the single measurement have a capability of covering an area of from a few millimeters to several square meters of its wide range in the application of its measuring. So as we are discussing that its capability, initially what is meant by active thermography? Nominally, it's an inspection system. That too, it's an automated inspected system utilized as a scanner. Particularly, we would like to call it an image scanning unit, particularly designed for detecting the defects in the composite structures, which is designed and built for high performance aircraft. So, coming to the working point of it, how it used or referred in order to working factor. Based on the induction or influence of this heat flow in the parts that to be inspected, the heat which is being propagated inside the objects that affects directly the temporal behavior and of the surface temperature. So whatever the heat that is being propagating in the form of this IR rays into the object in order to examine the composite structures of the object. So whether it has been confinedly having the bonding nature or not, whether it has been holding with respect to perfect properties, mechanical properties, or its solidification factor during the casting process or not. And if there is any flaws or air bubbles or voids that are being existing in the case of this casting process. So this and all will be getting clearly verified. But the internally agitated temperature, which will be having the higher than the surface level or the normal atmospheric level, which will be in contact with respect to the surface level, will be a temporal behavior of the surface temperature. That's a major conspiracy here. Particularly, these all will be getting observed with respect to this infrared camera, with the help of this infrared camera, which is capture the data, analyzing the data up to a structural level, internally grain size up to the grain level, whether is being grain growth is being increasing or else decreasing based upon the um, examining process by passing this IR rays with a particular confiding of temperature in order to examine the internal structures of the parts. And is there any of the defects, minute cracks or micro cracks or mini cracks existing, or any of the voids or porosities that has been generating, etc. So this is the concept of examining considerations. Hence, this is the projectors, infrared projectors, and this is the IR camera is to inspect the projected infrared rays parts position where the infrared rays are being projected over the object. And the reflectors will be analyzed in the display screens. So wherever the cracks has been identified, the frequency variations or modulations will clearly induce its fluctuations, that too to a confined lens or confined areas. Clearly, if at all any of the defects in the form of cracks has been identified, and to which length it has been identified, to which deformation it is being taking place. Is it in a straight line motion, or else any of the consecutive motion, or else any of the conditional asperities will be confiding to its nature. The automation of this active thermography system will be, it consists of a measuring head and a tablet computer as displaying with respect to a diagram which is showing on the screen. Normally, the IR Smart Eye 320 giga electric volts infrared Ethernet camera. So the confining area of the material utilized for scanning with respect to camera is 320 GeV, which is operated with respect to the infrared rays. It controls with respect to the integrating of electronics, and the halogen lamps which are being adjusted for both the ends that are displaying over the screen generates the infrared rays. And this camera of a 320 GeV will capture the entire analysis that are being considering internally was displayed in the pictorial representations. And particularly to a confined areas, it can be mobilized from one part to the another part as it sticks on with respect to a particular wall implications in order to identify clearly as in with respect to the area. So what are the certain benefits that are being considered in the case of this active thermographic technique? Normally, this inspection process is done in a series of tests, without any background deviations or background call up of NDT techniques. Even some of the defects, such as the hidden defects, such as the internal cracks, the disbondings, or delaminations in metal and its layer wise of formations, or the plastic materials clearly examined in the case of this active thermographic technique. Here, no system calibration is required in order to examine or progress the examining process. It's having the capability of inspecting most parts at minimum time. So within the less time, high quantity of objects used to be inspected. The complete side of an A320 rubber will be checked in 2.5 hours itself. So it's an nominally it takes in any of the another NDT methodologies, it confines with respect to 3.2 to 4 hours of time period for commencing the inspection technique for its identification factor. But in the case of this active thermographic process, it takes less time when compared with respect to the other testing methodologies. Coming to the point of this laser ultrasonic systems, this is also one of the ultrasonic testing we have clearly studied the ultrasonic testing process, that the echo methodology plays a major role in order to examine the internal voids or cracks that are being existing within the object will be confided or observed very clearly even in the micro range. A laser technology in an mutation with respect to the ultrasonic plays a major role indeed to identify up to a micro level of inspection range. Hence, the terminology here clearly specifies that laser ultrasonic systems. So laser ultrasonic systems. There's a non-destructive inspection system, very much widely used in the case of structural integrity of composite materials. So nominally, in order to increase the strength or bonding or to be capable with respect to the mechanical properties, incremental in strategy, composite materials plays a major role, and it's used for manufacturing conditions. Nominally, ultrasound is a method to generate the ultrasonic signals. Even in the case of remotely, in order to aid the laser technique with respect to the integrating with the ultrasonic technology. It does not require any physical contact between the probes and even the samples. So probe will be directly with respect to the contact of maybe in contact or will be a slight indirect contact with respect to the measuring device, but leads to a sample probes. And that probe will be getting monitored by utilizing the remote device, which is existing with respect to the operator, which is away from the probe. Confinedly, we can call it as a robotic device, which will be observing the entire inspection module or the object in an enclosed surface area will be monitored by the operator, which is placing externally, that too with remote signals passing with respect to this laser signals. So what is that laser UT? Laser ultrasonic signals. So nominally we will be calling that entire the equipment as a laser UT, ultrasound technique. So this laser ultrasound technique system, particularly laser ultrasonic testing, is a system which is automated by having this ultrasonic testing unit, which is used for detecting the advanced composite structures, even in the case of this micro range, which will be building for high performance in the case of this aircraft. So nominally, composite materials in the aircraft are used to dissect very much clearly by utilizing this technology. It's used in pulse echo, ultrasound, that's made easy to process or access, used to generate or penetrate into the materials with the help of these laser beams that generates these ultrasounds, and it's scanned for across this testing surface. And this is the technology or ultrasound generation that works with respect to mechanism called thermoelastic expansion. Particularly in this process, a pulse generation laser is detected at the surface of the material under the testing process. And at that particular time, the beam which is being generating is observed into a shallow volume of the material for rapid absorption of this pulse laser energy that creates the temperature factors and results in expansion of the materials. Nominally is called the stress wave. That particular stress wave is called this ultrasonic waves, which is generated with respect to high echo factors. See here, repulsed, repulsed or unregular glaser that used to monochromatocytes here, the shellagulus, and generates the heat effect to echo and transmits over this object. And if at all it penetrates through the materials with respect to the probes, and the detections will be examined with respect to the objects. This is the technique. These are the objects that will be identified. These are the scanners, and generation of the laser and passing with respect to the detection of this laser, and inframeter is placed for optics and generating these forces towards this scanners and identification of the entire pictorial representations or dynamical motions of this composite level up to the composite level commencement in the working progress. So the results which are being captured to a micro level at the internal structures of the walls as displayed in the interface, user interface. So the deviations that are being occurring has been displayed with respect to the heights and peaks and bulging of its accentuations, deviations in its deformations and its crack growth or grain growth. Upon scanning, used to clearly observe it. And this is the A scan process, this is the B scan process, and this is the C scan process. What are the major benefits of this particular progress? This reduces the time factor in order to identify. No tools or fixtures are being required for examining process because it's an NDT and directly this radiographic technology or laser beams that will be getting passed with respect to an echo generated in the ultrasonic range. But the operators need to trained up, nothing but a skillful worker is necessary in order to operate it. No calibration is required. No special foundation is required for it. No coupling for any kind is required for it. There's no any direct contact of the probe with respect to the surface of examining work part. But scanning surface of the complex shapes which are having the irregularity in its shapes or else the rough surface finishings at speeds can be having a limited to some extent and having 10 times faster than the conventional ultrasonic systems to be examined. These are the better benefits of identifying the defects within the active thermography by the case of active thermography and the laser ultrasonic testing methodology, particularly in the case of this aerospace manufacturing industries, the airplane parts preparations. So these are the different technologies or non-destructive techniques utilized for examining in the case of this aerospace technology. And in the tomorrow's class, we would like to progress with respect to the new application. Thank you.